Hello. So I put links below about this. I did procedural movement that includes procedural animation for this um, robot. So there's this lower part. So let's talk about uh, one of the most important part, control rig. So procedural animation. So in procedural movement, I am moving effectors that placed at the end of the leg. So let's see. Here is my control rig. This is the root control. This is static part control to rotate it, and this is the ball controls to move the legs. And when we stop setting their positions, we can see how it's moving. So as you can see by this control, it is also rotating. So I will explain every part about this. But first of all, let's examine this skeleton. So inside Unreal Engine, it has this axis. As you can see, this is the world for static part, for the root, and for each leg, it is rotated. So the minus Y is the primary, and the X is the secondary. And Z is up for each bone, for the leg. So here in control rig, first of all we set some parent constraint for root and static part controls, so we can rotate it. But it is actually rotated by multiplying initial rotation by rotation from the input normal that we calculate inside animation blueprint, and using this custom function that calculating rotation that we need. Maybe, and I'm sure you can do this different way, but I did it like this. So next, there is just the loop for the leg. Then I set variables, so I can call it by variables. Inside this function, there's three parts. First of all, about ball control orientation. So when we move it, you can see it is rotates. So it is rotating, and when it rotates, it also rotates leg control that locates inside this part. This is the ball, this is the foot, and this is the knee, and this is the leg. And it is rotated by this constraint. Then we have aim constraint for the ball control. So ball control always looking at the leg. Ball control always looking at the leg bone, using this aim axis and this up axis and direction from the static part control, since we want to maintain this up axis when we rotate static part control, when we move on angled surfaces like this. So this rotation constraint rotating leg control by ball control. Then we rotate ball control by looking at the leg bone, and then we rotate leg by leg control. So in the end, we move ball control. It is rotates with its rotation. It rotates leg control that rotates leg bone. So this is how this works. So this is how it works. So next we have a knee control location and rotation also, and leg rotation vertical. So when we move control like that, we want to first of all, I want to first of all rotate a leg, then rotate knee, and then rotate foot. So last two rotations is I will explain it later, but first I'll explain right now. So for this leg knee rotation, doing basic fabric AI knot, and all what we do next after this, we just changing position by Z, since in the start on the initial pose we have offset, which we need to adjust to being able to stretch leg. So if I remove that and move this control, we can see that it has this initial offset. So we have to move this constraint. So this basic fabric knot would rotate leg properly, and knee, since it has to be rotated for basic IK knot. Oh yes, this is part. What this is do? This is simple. You can do this even simpler. It is calculating a distance from a leg to the ball control initial, and compared it to distance current from ball to leg to ball control. And when we move further from the leg, we want to decrease Z, so we make remap for this and make lower percent of the height from initial position 25%. So we multiply, in the end it is multiplied by 25, the maximum stretch 25%, and rewrite it. So it is situational. You have to find your numbers. It depends on your leg length. Since I have maximum length of 560, something like that, and with 25% of Z height of knee control, I have enough rotation for the leg, as you can see. So the next is basic IK knot. It is pretty simple, but it requires some like black magic, because I'm not sure how this works. It is working, as you can see, since it's moving. Maybe it is not working as it should be, but it is working. So the first one is item A is knee, item B is foot. So this, and then ball, the bone. And then effector transform, we have ball control. So this is control. And then we have a primary axis Z positive and secondary axis Z negative. And pole vector, we have location from transform, make absolute, and 300 by Z. And pole vector space, we have control or root control. So the reason why I am speaking all this, saying all these words, is because I'm not sure how it is working, but it is working. It is working. It maintaining all positions that we need to maintain for the robot animation. Like, it is working. So next we just get this array from the input that we set inside animation blueprint, that I will show in the next tutorial. Well, I will call tutorial, but it's not a tutorial, it's just a showcase. So, like that. And rotation.